Restoration of endodontically treated teeth. I'm Professor Hussein Al-Huwaizi. Now, in endodontics, we always face, after endodontic treatment, that we have a tooth that is very weak. Why is that? Because after endo treatment, dentine is significantly weakened. Around about 9% of its strength is lost. And this is due to decrease in water of the dentine. It becomes more brittle. So we have to conserve as much remaining tooth structure as possible. We can do that by, first of all, the simplest way, and this is direct composite restorations. The minimal amount of coronal structure here, if it is lost, just like this case, whereby the angle of the maxillary central incisor has been lost, we can restore it with a direct composite restoration. Now, why composite? Because composite has a compressive strength of about 280 MPa, and the Young modulus of the composite is 10 to 16 GPa, which is really comparable to dentine properties. Sorry. If the destruction is more, and especially in the posterior teeth, here we can use composite or ceramic onlays, what we call endo crowns. We can use them, and this endo crown combines the post in the canal, the core, and the crown in one component. So it's one component: post, core, and crown. Or we may use what we call the onlay or the overlay. So it starts with the simplest, which is the inlay, whereby the wall of the cavity is diverged and the inner slope of the cusp is destructed. So we restore this area. If the destruction has exceeded to the height of the cusp, we extend our restoration to the height, and we call this onlay. If the destruction is more and it has destroyed more of the cusp, so we call this an overlay, it covers the cusp as a whole. Previously, we used to have the restorations made from gold or metal with facing, but nowadays we can use composites, ceramics, to compensate the destruction of the tooth. We can use the scanner, intraoral scanner, to take an impression and send it immediately to the lab with very high precision, and it is really quite available nowadays. Crown coverage can be done when we have got multiple restorations in the same tooth, and there's a lot of tooth loss, tooth structure loss. So in this case, we may end up doing a crown rather than an inlay or overlay or whatever. Second, we have to protect and cover the occlusal surface of the tooth structure, for example, onlay or full coverage. If we can see this case, this premolar and the molar, this has an old, or they've got old amalgam restorations with signs of recurrent caries. So when we remove this amalgam and we remove the caries, we will end up with very thin cusps. Here, these thin cusps, they have to be protected. So we either do an onlay to protect the cusp, or we do a full coverage when we see that the tooth structure loss is more than anticipated, so we cover it, the crown. In endodontically restored teeth, we may need to make a post, and this post really gives a retention to the core, but it does not strengthen the tooth. Adequately condensed gutta-percha is important. We have to condense the gutta-percha very well because we need to remove part of this gutta-percha coronally and in the middle region. We do that with a rotary instrument or a hot instrument. This rotary is what we call the piezo drill. It drills the coronal and the middle region. It's very important because this space is going to be filled by the screw or a fiber post. So the clinical guidelines for post length, you can see here, this is a root that has been filled by gutta-percha. We have to remove the part of the gutta-percha so that the post or post and core fills this space. But how much is this space? It should be about 3/4 of the length of the root to give it maximum retention. Or sometimes in short teeth, we have to leave no less than 5 millimeters of the apical gutta-percha, because this gutta-percha is the least amount needed to ensure that we have got a tight seal in this region. The post should be confined to the straight part of the root canal. So when we've got a curved canal, we have to stay drilling the gutta-percha or removing gutta-percha in the straight part, because the piezo drill does not enter in curved areas. The post width should be as wide as the width of the treated root canal. When we finish our obturation, our post width should be just as wide as the prepared root canal. We should not widen it more, because if we widen it more, in this case, we are going to remove dentine, which is very vital for the strength of the root canal. You know, the root canal after endo treatment, it's brittle, it's weak. If we remove more dentine, that means that the root canal will be even weaker. So when we want to crown a tooth, our preparation has to be very, very clear. Our finishing line has to be very clear. Proximally, there should be a lot of good clearance, no contact with the adjacent teeth, and the margins or the contact angles, they have to be all smoothened, so the crown is going to fill or get seated on the tooth nicely without any interference. The post crowns, we may have a prefabricated post. We place it inside and we build the core, and then we place the crown on top of it. Or we may have a cast post crown, which is the core and the post in one piece. This is made from metal. You can see here that the post length is around about 2/3 or 3/4 the length of the root, and it is important to keep 5 millimeters from the apical gutta percha. Problems of post crowns: they may be bent, they may fracture, they get a lot of pressure on them, and this pressure might be sufficient enough to make such problems. Now, when we make preparation around a core, a post and core, or any crown, sorry, it's important to understand the ferrule. Now, what is the ferrule? It is defined as a 360 metal color of the crown surrounding the parallel wall of dentine extending coronal to the shoulder of the preparation. That means that when we've got a shoulder subgingivally, we have to have a color of preparation around the tooth above the finishing line. This is the tooth structure. This will make the crown embrace the tooth to the gingiva and preventing the movement of the crown and giving the tooth strength. At the same time, this is what we call the NSIS stress analysis. You will see that if the ferrule is not done very well, there will be a lot of stress in the cervical region. But if it is done nicely, the stress, which is red, you can see it. It will be distributed along the root. And you can see here, this is a tooth destroyed by caries. If we remove it, and this is quite good dentine, we place our finishing line subgingival, we make what we call the ferrule here. And this is very important for the crown seating. But when there is no ferrule, just like this tooth, which is already subgingival, here our restoration is going to be seated on the crown with no ferrule. So the adaptation will be less. This is really the good preparation with a very good ferrule, but of course I've got caries here. I have to remove the core, old core, and the post, clean this caries, and do another post and core, and then we do another crown. Now, prefabricated posts, they may be from stainless steel, titanium, but they are threaded just like a screw. they've got problems. For example, they have to be cemented, and there sometimes spaces stay, and these spaces may harbor bacteria, or these screws may get indented inside the dentine and make a lot of stress on the tooth structure, and it may fracture the tooth, or we may have corrosion products with the presence of moisture, and it will end up with fracture of the tooth. Now we've got what we call the fiber post, and this is made of fiber which has got properties of, or the resiliency just as good as the dentine. We place our fiber post inside the tooth and lute it with composite luting cement. It will give strength to the already weakened root canal. Oh, sorry,